Hello everyone, welcome back to Everything Swift. First of all, Happy New Year. Hopefully the first week of the new year wasn't too bad and you guys are really recharged for the brand new year. I do apologize for the lack of update. I was just taking some time off YouTube and at the same time just trying to learn more iOS material stuff, which I will be putting out more this year. So I will still be doing Leetcode stuff, but I'm planning to just share with you guys what I've learned from the iOS app development perspective. But yeah, so just stay tuned for those kind of material. But for today, we're going to tackle Leetcode question 199 titled Binary Tree Right Side View. So let's see what we have to deal with today. So basically, we are given a root tree node type object, which is optional, and we are supposed to return an array of integers. So as we can see in the diagram here, pretty much this example here, like this particular diagram, is basically representing the tree node here that we are given in the parameter. And the tree node has two childs, right? Which is the left child and right child, as you can see in the tree node object here. What we are supposed to do for this question is only return the values of the right side tree. So we can see here that the root node is 1. It has a left child of value 2 and a right child of value 3. And the left child of value 2 has then a right child of value 5 and 3 has a right child of value 4, right? So basically, we are just going to ignore everything on the left side. So 2 and 5 is not, we're not interested in that. We are only interested in the right side of the tree. So as you can see here, the answer is 1, 3, 4, right? So 1, 3, and 4. 2 and 5, we don't really care about that, right? So, what's the strategy to tackle this question, right? So, in most of the tree-based or binary tree question, traversal, we can do it in two formats, right? Usually, a DFS, which is depth first search, usually revolves around recursion, and we can use breadth first search, which in short form is BFS, which usually revolves around iteration. And I find it BFS is quite easier to understand, or at least they have much clearer pattern, recognizable pattern across questions. So today I'm going to demonstrate how we are going to use BFS, breadth first search, to solve this question. So essentially, BFS usually has a queue, and how queue data structure works is basically it's a first in first out operation. So we are going to append the tree node to the queue, and we're going to traverse the queue. And while traversing, we are going to basically just append the right node value, all the nodes value for only the right side of it. So I'm just going to jump straight into the code, but basically that's the strategy. We are going to use a BFS. There's going to be queues, and there's going to be an array, which is just the output that we're going to return. And while traversing it, traversing the queue, we are just going to append the right side. And that's essentially it. BFS, queue, and yeah, I think I'll just jump straight into code. It'll be much clearer. So if you guys have been following my account, you guys know I like to just do a quick check here whether the root node is nil or not. Basically, it's just a quick optimization here. So if the root is nil, basically we don't really care about the scope of this function. We can just exit. So in the world of Leetcode, depending on the question, maybe not all the question requires you to do this, but it's just a habit of mine. So even in production code, I usually just kind of like write this and return out as fast as possible. Just a minor optimization. So once we check and be sure that the root is not nil, since we are going to use BFS, we are going to use a queue to store the root. We're going to traverse this queue, which essentially means we're going to traverse the entire binary tree here. So we create an array for it because we're going to traverse it, and the output is the answer here, which is of type int. So to ensure that we are always going to traverse and we safely exit out from the loop of this BFS loop, we are just going to have a while loop to check whether the queue is empty or not. right? So long the queue is not empty, you just continue. The loop it just lives on. And here we're gonna get the count of the queue.count, and then we're gonna have another loop which is a for loop, for.count. And here, what we're gonna do is get the current node inside the queue, right? So queue is first in first out, so we're gonna do remove first, right? So just a quick pause here. This pattern here, like creating a queue to store a certain object inside, and has the while loop outside, and then the getting the count followed by a for loop. This is a very common pattern that we can see in most of the BFS solution. So just kind of like take a step back and try and recognize this pattern. And if you do any question that you come across that is suitable to use BFS, you will notice like this pattern is quite similar across all BFS questions. So just kind of keep a lookout for this pattern, recognizable pattern. So here we because we are using the queue, we're going to remove first, get the current node out, and then what we're going to do is check if there is a right node for that current node, right? So we're just going to check this current node dot right, and say if we do have a right node, this is where we append the into the queue, so that we will continue traversing throughout the tree, right? So here's right node, and then left node as well. We just want to check that current node dot left, right? And if it's not nil, and we are only doing all of this because we want to traverse the entire tree, right? So we have to take care of the left side as well, but we are not going to add the value of the left nodes. So to do that, as we can see here, we are adding the right node first to the queue, and because it's the first in first out operation, what we can do to get all the right side value is to check the index of the iteration. So if I equals to 0, that means it's the first value of that particular iteration. What we're going to do is just get the answer append current node dot val. I guess I have to force unwrap it here. You guys can also do it safely, but I think for the purpose of time and in Leetcode, I'll just force unwrap it here and get the current node's value. And we all know that it will be the right side because we're appending it to the queue first, followed by the left, and we're just checking if that particular for loop is basically the first one. So since we are only interested in the right side value, then that should be it. We can just return the answer. So just a quick recap, we basically create a queue. We store the root into an array because we want to traverse it, and then we're going to apply BFS to it. So the common pattern is to have like a while loop checking whether it is nil or not. If it's not, the while loop will continue to be alive. And then within it, we have a for loop, and how big or how many iteration it does is basically the size of the queue. Then within the for loop, we basically, because queue again, first in, first out, so we're going to remove first, get the current node. And in this question, what we're supposed to do is basically get the right side value. So we append the right side to the queue. And we also check the left because we have to traverse the entire tree to make sure if there's any right side values that we need to add into our answer. So we append the right side first, and then we append the left side. So to ensure that we only get the values of the right node, we just check in each for loop iteration here, we check whether it is index 0. If it is, then we add it to our answer output to get the current node's value. Then with that, essentially we just return. And that should be it. Let me just run this real quick. Hopefully I get it right. There we go. Let me just run again for all the test cases. Looks good. Let me just submit this. There we have it. That is the solution. Looks good. So yeah, hopefully you guys understand this solution. We just use BFS to solve this thing and traverse the tree. So yeah, just stay tuned for more videos like this. I'll definitely put out more solution Leetcode videos using Swift. And also stay tuned for the iOS material. I'm definitely going to focus on that for this year. So appreciate it if you guys can spread the word and share my channel. If you guys haven't already, please feel free to subscribe to the channel. With that, thank you, take care, and bye bye.